I always wait till it says like recording just because I feel like it needs to say that. There we go. All right, so we're going to talk about SohCahToa today, and I'll play the song at the end. But have y'all heard of SohCahToa before? Some people have? Who has? Raise your hand. Let me see. Okay, a few people. Depends on what teacher you probably had a couple years ago, right? If you got to this. All right, SohCahToa is just a way to remember. Y'all know those buttons on your calculator? You ever seen them that say sine, cosine, and tan? And you're always like, what are those buttons? Are we ever going to use these buttons? Right? They've been on there forever. That's what we're going to use today. Okay? So this is sine, which is the so part of SohCahToa. Cosine is the ka, and tangent is the toa. Now you'll see SohCahToa written two ways. This way, all out, you know, whatever that's called, horizontal. I like to write it this way. Number one, it looks cooler, and number two, it helps you because these are actually going to be fractions that you're going to use. So it already shows you the way to write it in the fraction. So up to you how you write it, but you need to memorize it. Okay. What this tells you is the following, and this is pronounced sine, like fine with an S, okay? So don't say sin, don't say cos, don't say tan. You need to say the whole word, sine, cosine, tangent, okay? It's one of my pet peeves. All right, so sine, sorry, my OneNote keeps doing that. Is O over H, which is opposite. What do you think the H stands for? We're talking about right triangles here, right? What does the H stand for in a right triangle? What do you think? Hypotenuse. Okay, so sine is opposite over hypotenuse, meaning the length of the opposite side over the length of the hypotenuse. Okay, we'll get to there in a second what the actual fraction looks like for this question. Cosine is A over H. So that is, we know the bottom's hypotenuse. Anybody know what the A stands for? A, D, J. Adjacent. Adjacent means next to, right? I'm adjacent to the table, the adjacent side. And TOA is tangent, which is opposite over adjacent. Okay? That's what all of those mean. I know it takes a while to write on your tablet, but type it in or write it down or go back later and fix it. SohCahToa is only used for right triangles, okay? A right triangle means it has a right angle, right? Keep saying the word right 8,000 times. And over here, we have a right triangle. How handy. All right, the other thing you need to remember is that sine, cosine, and tangent are always next to an angle. Okay, it's always sine, cosine, or tangent of an angle. Okay, and then it's the fractions. So if you don't remember anything else right now, remember sine, cosine, and tangent are always having to deal with an angle right next to them. You should not see tangent 3/5, right? Like it's tangent of an angle equals 3/5 or whatever it is. So just remember that you always have an angle next to those functions. Those are actually functions, okay? All right, so when we talk about this exact triangle, you would get a question that would say, give you the picture, and it would say, What is the sine of 53 degrees? First thing you notice, next to sine is an angle measure, right? Because you always have an angle next to those functions. And then, oh my gosh, my pins are driving me crazy. Okay. You're going to look at the triangle and you're going to do O over H because that's what sine is for SohCahToa. Okay? There's a lot of information today. Stay with me. Sine is O over H. So I'm going to go to my triangle and I'm going to find opposite and I'm going to find the hypotenuse. Okay? We are looking at this angle here. So we're going to label the triangle. Okay? Opposite to 53 degrees would be what? 6, 8, or 10? 8. How do you know that? Because if Claire was standing right here in this triangle, because she likes to do that, okay, and she is here at this angle looking out, the opposite side would be the side she would see. It's also the side that's not touching the angle you're talking about, right? Either way you want to remember it. That's the opposite to that angle. We also need to label hypotenuse, right? We need that for sine, O over H. So the hypotenuse would be, which side? 6 or 10? He said in the video how to recognize it. Do you remember? Opposite the right angle is always the hypotenuse. In a triangle, the longest side is opposite the biggest angle. Did you know that? Think about if it's this is very scientific. If the angle's opening up like this, right, the side opposite it will be longer. The shortest side is opposite the smallest angle. Cool, huh? All right. That means if I have O, H, and A, then 6 must be A for adjacent. Okay? It's very important to label the triangles because you're going to get confused. All right, so sine of 53 is O over H. So we're looking at sine of 53 degrees is O, which is 8. 8, H is 10. So now we have a ratio. Okay, sine, cosine, tangent are always going to give you ratios. So now all we have to do is simplify that fraction. So we're going to get what? 4/5. That's the answer that we're looking for, 4/5. Questions so far? That was a long explanation to get to a fraction, but it's all important information that you're going to need. Okay, Connor, you good? Okay. Next, we're going to do cosine. So we're going to follow the same pattern. We're still talking about 53 degrees. We're still using SohCahToa. So we're on the ka part. So we're going to say A over H. So then we're going to fill in A and we're going to fill in H. Using 53 degrees as our reference angle, what we're referring to, A is going to be 6. H is still 10. Okay, so I'm following A over H, 6 over 10. That's why when you label the sides, it makes it a lot easier. So cosine of 53 degrees is, simplify the fraction, 3/5. Questions how I got 3/5? All right, go ahead and try the last one yourself. Do tangent. All right, Piper, what'd you get for your first fraction before you simplified it?
8 over 6.
8 over 6, good. Then what'd you get simplified?
4 over 3.
4 over 3, good. Okay. Any questions? Color have I not used? Green. All right, so that's how you find sine, cosine, and tangent. When they give you the angle, you label the sides, you follow the formula. Okay, the formula is SohCahToa. Got it? Good, thumbs up. All right. Now, sometimes they will ask you for sine, cosine, and tangent, and they won't actually give you the angle measure. They'll just say the name of the angle. This is where people tend to get confused because there's not a number next to cosine, tan, and sine. But it still means an angle, right? Remember, next to cosine, tangent, and sine is always an angle. Okay? So, when we talk about angle H, we are talking about this angle here. So again, we want to think about SohCahToa. So cosine of H, I'm getting my random name picker, Lindsay. Cosine is what over what, Lindsay? SohCahToa.
12 over 37.
Oh, just give me the letters.
A over H.
Yeah, but you're right. I just want to write the letters first. All right, so cosine is A over H, so she's correct. We're going to label it first just so everybody's on the same page. According to angle H, 12 would be adjacent, right? 37 would be hypotenuse. So like she said, we're going to have 12 over 37. Again, when it asks for cosine, sine, or tangent of an angle, you're going to find me a ratio, a fraction, okay? People mess that up a lot, so I'm repeating it. Now, on your calculator, you're going to type 12 divided by 37, and you're going to hit enter. Because it says rounded to 3 decimal places. And we're going to get approximately 0.32432 ... Every year I have about 5 people that have no idea how to round. So, very quickly, to round to the 3 decimal places, what place is this called? Thousands, good. Okay, you look to the number to the right of the place you're rounding to. 5 or more, raise the score. Remember that dumb rhyme? It works. 4 or less, let it rest. Okay, that means this is going to stay 0.324. That is the answer that we will be looking for. Okay. Please make sure you understand how to round. If you don't, Google it, watch a video, practice, okay? Not going to teach that, not going to practice that, but all right. Next one. Isabella, for tangent of H, what 2 letters are we going to use for tangent? O over A, good. So looking at angle H, do we know the opposite side length?
Yeah.
We do? It'd be over here. What is it? Did you already find it?
Oh, no.
No, we don't know it, right? So what do we have to use to find that side? Pythagorean theorem. So we can say 12 squared plus, I'm going to call it FG, right? Squared equals 37 squared. So that's the side, right? FG. Somebody tell me the answer. Y'all better do it before I do it. Y'all are slow. 12, 25. What's the square root of 12, 25? Do y'all have calculators?
13.
What is it?
15, 13.
Nope. Should my answer be greater or less than 37? It's less because 37 is the longest side of the triangle, right? So if I get an answer bigger than 37, I did something wrong. Is it probably longer than 12? Probably, although don't go by the pictures sometimes. So what does FG equal? 35, okay? So Isabella, now we know the number. So what's our fraction going to look like?
35.
Right, 35 over 12. And you can find the decimal approximation. Gives me 2.91666 dot, 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 dot. Again, we are rounding to the thousandths, which is this third place. We look to the right. 5 or more, raise the score. So it's 917. Please do not round twice. I have a lot of people that will round once and then round again, just one time. Okay. All right, any questions so far? All right, go ahead and do the last one yourself there. While I try to get my pins to work. There we go. Did y'all notice something changed? The angle changed. Did everybody notice that? I noticed that my pen doesn't work. It's no longer talking about angle H. It's now talking about angle F. My pen's frozen. All right, randomizer. Boop, 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 boop. Jalen, you're up as soon as this page decides to upload. Okay, well, this is still working too, so. I just need my pen to work. All right, so sine of F means we are now looking at this angle over here. So our opposite and our adjacent are going to switch places. Did y'all notice that? If you didn't, you can fix it. Okay. So Jalen, what's the opposite side to angle F? 12. Okay. And for sine, we're going to use opposite over hypotenuse. Okay. So hypotenuse is still 37. So please be aware, when you change the angle, the opposite and the adjacent switch places. Okay, so this is now opposite for the blue angle, and this is adjacent for the blue angle. All right, Jalen, what'd you get for your decimal? And that's rounded? Wait a minute, that's what we got for the first one. Crazy. Did y'all notice that? Now you did, right? We got the same thing, which is correct. We should get the same thing, and we're going to talk about why in just a second. All right, we're going to skip this part, and we're going to go down here to this question, because this is really important for this unit. Stay with me. All right. Given sine of A is 3/5, label the side lengths of this triangle. All right, how do we do that? Well, remember, this letter next to sine represents a what? An angle, right? So they're talking about angle A. Okay. Have y'all ever seen this symbol? It's like an O with a, I can't draw it right here, with a wavy line through it. It's a Greek letter. Anybody have an idea what Greek letter it is? I guess not if you've never seen it. Theta, have you heard of theta? Theta, gamma, delta, like a sorority or fraternity, I don't know. That's a made up one. You will see that a lot of times in math when there's an angle that you don't know, okay? Typically this is used for an unknown angle in math. So I just want to make sure you're aware. If you see me do this, that's what that means. That's an unknown angle measure, okay? Theta, that's what it's called. All right, good to know. So we're going to label this. Sine is, well, let's think back to SohCahToa, right? SohCahToa. All right. So 3 would represent which part? O, right? And the 5 is the hypotenuse. So label the triangle based on that, meaning this side is 3, this side is 5. Now we're going to need the third side. So what do y'all think it is? What is it? We talked about it in the video. Real quick. Somebody figure it out. Pythagorean theorem. True? You're up. What is it? Okay. While she's working on that, y'all start doing this over here. All 6 of these. When you get it, yell it out, True. Mason's got it? Mason wants to help. 4. Good. Because you're all going to need that for cosine of A. All right, please understand here the angle changes on the second column. Okay? Give me those ratios for all 6 of those. Go. All right. Charlie, what's cosine of A? Okay, it's not 3 over 5 because cosine is a over h, right? So when you go over here and you want to label it, which is a little hard because it changes, but for a, adjacent would be this side with the 4, and then the 5 would be the hypotenuse, and this would be opposite. Do you see why that is, Charlie? For angle A?
Yeah.
Okay. So instead of 3 over 5, what's it going to be?
It's going to be
Right, 4 over 5. Good. Okay. Jeremy, tangent of A. O over A is tangent. Okay, so Jeremy, what's the opposite side to angle A? The number, what's the length? 3, yep. And the adjacent side, Jeremy, is what? This is angle A. This is adjacent, right? We labeled it? 4, okay. Good. Sine of B. Now we're changing angles, right? Now we're talking about angle B, which is down here. So now this becomes opposite for angle B. This becomes adjacent. Hypotenuse stays the same. Okay. Audrey, what's sine of B? All right, well, we're doing it now. So it's O over H, right? SohCahToa, right? Yep. There you go. Nailed it. All right, cosine of B. Alex. A over H. Right, which is 3/4. And last one. Allison. Tangent is O over A from B. So what do you get?
4 over 3.
4 over 3. Cool. All right, those are all correct. Now, what I want you to do is think about this question right here. I want to give you 30 seconds to look at these numbers or write them down if you haven't. What patterns in relationships do you notice? Go ahead and write down a couple of things you notice on your paper or think about it in your head. Wait, don't tell me yet.
I have a question.
Oh, what?
Is it the H equal? Yeah, that's what I was.
Oh, shoot. This one right here?
Yeah.
Thank you. Okay, that's better. Thank you. Now you'll notice some more patterns. All right, Archer, what do you notice?
Well, there's 2 of the same numbers.
Yeah, which ones are the same? Like, tell me in terms of sine or cosine or whatever. What do you notice? Which ones are the same? Tell me the numbers that are the same. Just the fractions. That's fine.
So 4 over 5 is the same, but it's
So there's 2 4 over 5s, right? Okay. So let's look at what that is, right? Sine of B is the same as cosine of A, right? That's right. Okay. Do y'all agree with that? They're the same. Okay. What else? Claire, what else did you notice? Okay, and in math, Claire, what do we call that when they're flipped upside down? Nope. Who knows? Tangent A and tangent B are, ooh, closer. Ooh, somebody just said it. Reciprocals. Do y'all see that? They are reciprocals. Reciprocals. Meaning, yes, they are flipped upside down. Claire, why do you think that happened? Well, they're both O over A, right? Isabella? Because the O and the A switched, right? You remember how I wrote it in two different colors? So tangent of A was 3 over 4 because that was O and A, but then when I changed to the other angle, the A became the O and the O became the A. That's really confusing. Okay, but that's what happened. All right, there's one other relationship here. What are we missing? What else do you notice? Jeremy? It's probably the two that I haven't highlighted yet.
Sin A.
Sine. Sine, not sin.
Sine. A and
Cosine.
cosine. B are the same.
Yeah, they are. Aren't they both 3/5? They sure are. Cosine of B equals sine of A. Same reason as the tangents are flipped, right? For sine of A, it was opposite over hypotenuse, 3 over 5. For cosine of B, the opposite became the A, right? They all switch around. All right, this is really important because there's sort of a theorem that you need to understand about complementary angles. Now, why are we talking about complementary angles? Well, let's look at angle A and angle B. Let's talk about this triangle for a second. We have one angle that is 90 degrees. Okay. What do we know about the sum of the angles in a triangle? What do they add up to? 180, right? Because it's like half a rectangle. Okay. 180 degrees. So if this angle's 90, what is A and B going to add up to? 90. They add up to 90 degrees total. That means they are complementary to each other. They're like, ooh, I like those pants. Oh, thank you. I like your hat. Right? Just kidding. They complement each other, meaning they add up to 90. So the theorem is when you have complementary angles that are equal to 90 together, sine of A and cosine of B are equal. That's what we just showed. Tangent of A and tangent of B are reciprocals. Reciprocals. You're going to see this in all different forms in this unit, okay? So you might see where I say, okay, well, sine of A and cosine of B are equal, then sine of 30 would equal cosine of what? Anybody know? They have to be what? What do these angles have to be? Equal to 90 degrees for that to be true. Y'all with me? They're complementary, right? They have to equal 90 for their sine and their cosine to be equal. We'll do more of this later, but this would be 60, right? And you could draw a triangle and you could see, okay, well, if I have this right triangle and this is 30 degrees, not to scale, then the sine of that, 4 over 5, would be the same as the cosine of 60, because that angle has to be 60 if that's 30. Piper, stay awake. Okay? The sine is equal to the cosine. It'll make more sense the more you practice with this, okay? You've got to do the homework tonight or you will be so lost the rest of the unit. Okay? So one more example. Let's think about this complementary angle business. All right. Suppose that P and Q are complementary. That means they sum to what? 90. That means we're dealing with right triangles. Okay. So we have a right triangle situation. We have angle P and we have angle Q. Now, I don't know what they are. It could be 30 and 60. It could be 27 and 63. It could be 1 and 89. I don't know. But I know they're complementary. Okay? So they add up to 90. So if cosine of P is 4 over 7. Okay, remember cosine, SohCahToa. Ka would be A over H. Then adjacent to P would be here, right? H would be here. Could I fill in these numbers and draw a picture and figure this out? Sure. Is there a shorter way? Yes, but that's okay. This would be 4. This would be 7. Then what does this tell me about angle Q? They're asking. What do I know about Q? Well, based on the formula we just talked about, if cosine of P is 4 over 7, then sine of Q is what? 4 over 7. Because this would be opposite and this would be hypotenuse. Okay? This one hurts the brain a little bit, but it's there, it's happening. All right? That's what I know about Q. Also, if tangent of P is 9 over 10, I cannot draw a straight line. P, Q. So tangent of P would be opposite over adjacent. So opposite adjacent is 9 over 10. Then what do I know about Q? Well, I'm dealing with tangent, so I know that tangent of Q is 10 over 9. It's the reciprocal. Okay? Because all of this works because they are complementary angles. Okay? That's why you just have to kind of understand the theorem, but you can always draw a picture and kind of figure it out. Okay? Your homework has more practice with this. It also has more practice with the stuff we did at the beginning, right? Find the value, give as reduced fractions. Reduced fractions. Okay, if it asks you to round, then round. Otherwise, leave it as fractions. This is what we just talked. Hold on, guys. It's too loud. This is what we just talked about. Okay, label the triangle. Figure out these values. Okay, please practice this tonight. The rest of the unit hinges on you understanding this stuff from today. All right. All right. Good work. I'm done. End meeting.